Good morning, good afternoon, and good evening to wherever you are in this crazy place we call home. Today I would like to teach you how to find the zeros and the multiplicity of the given function. All right, so we have x cubed multiplied by x minus 1 cubed times then x plus 2. So the first thing is, in order to find the zeros, you have to have it in fully factored form. And what that means is that you have to have some factor like a multiplied by some factor, we'll call it b, multiplied by then some factor, we'll call it c, etc. ... And we do have it in that form. And the reason why we want it in this form to find the zeros is because, well, I have 20 some odd videos out there. So check that out. Actually, I went through a lot of detail in each one of those. But the basic idea here is that, if this term goes to 0, then I could care less what these two terms are because this whole side would then be 0. All right? And that would then give me the value of 0 for the function, which then is the 0 of the x value. Right. Anyway, so what we have to do now, once we have this in fully factored form, is we basically break this up into three equations. So we do x cubed equals 0. Okay, we'll take that factor, set it equal to 0. Take the next factor, x minus 1, and set that equal to, and you can cube it, and set that equal to 0. And then do the last one, it's going to be x plus 2, and set that equal to 0. All right. Now, you don't really even have to write these powers, because the first step of each process is going to be to get rid of the power, right? And what you have to do then to the left-hand side is take what's called the cubed root, or you can just simply take this and raise it to the 1/3 power. Either one's going to work, but whichever one you choose, all right, they're both equivalent. Whichever one you choose, you also have to not only do that to the left-hand side, but you better do that to the right-hand side of the equation. And the cube root of 0 is just 0, right? So that doesn't really change. So that's why we don't really have to worry about that particular step. All right, so we get an x value here being equal to 0. When you take a cube root, actually I don't even have to, no, it's only 0, so never mind. I was going to tell you something about a cube root, but it's really not important in this problem. So the next step here is going to be to work on the second one. All right, take the cube root of the left, take the cube root of the right, and then it's going to be x minus 1 is equal to 0, add the 1 on over to both sides, and x is going to be equal to positive 1. And then last but not least, do the same thing for the last equation. Subtract 2 from both sides, and you're going to get x is equal to negative 2. Now what these are the x values, right, of the function, where the function should touch the x-axis, or cross the x-axis, right? So let's move these values now. So we found the work, right? Let's move these values on over, because I'm going to clean up a little bit of space. And just to kind of show you how this is going to work, right, I'm going to plug it into our calculator. So what you're going to do, go to your calculator. Hopefully you have a TI something or other. So go to y equals, all right, clear out whatever you were working on before, and go to x cubed, so x raised to the third, then open parentheses x minus 1, close the parentheses and cube that, and then open parentheses again and just do then x plus 2, and close the parentheses. I'm going to go to zoom and I'm going to go to standard, number 6. So it should bring me, brings me right to here. I'm going to try to zoom in. Let me see if this actually works nicely. Go to zoom and then hit number 2 and hit enter. Yeah, this works pretty nice. All right. So this one's a little tough to see, but if you can, there's definitely two areas that are very clear, right? The graph is crossing, now by the way, remember this is the x-axis, okay? So the graph is crossing the x-axis right at this particular location. What's the x value of this point? Well, that's negative 1 there at that hash mark, and that's negative 2. Wait a minute, that's exactly what we found before, right? Okay, so that's negative 2. And then it's also telling us, and this one's a little harder to see, but it kind of does dip below, right? It does dip below that x-axis. So the function here should also cross the x-axis at 0, it tells us, and it does look like that, right? That's x is equal to 0. And it should also cross the x-axis at x is equal to 1, which it basically does. All right, now, like I said, it's a little hard to see, and it's a little pixelated because it's not the best detail, but I think we can clearly see how that's working. Now, the idea here is to find the okay, so at least we have a nice little picture. Now, the multiplicities, okay, multiplicity is very simple. All the multiplicity is going to be is it's equal to the power, all right, of each of the factors. Now, if you don't see a power there, just put a 1. So basically, the multiplicity of this 0, so we remember x cubed, the 0 there was x is equal to 0, okay? So when x is equal to 0, the multiplicity, I'll just label it MULT, the multiplicity is equal to 3. When x is equal to plus 1 or positive 1, remember we got that from the second factor, the multiplicity there is equal to that exponent, which is just 3. And then when x is equal to negative 2, remember we got that factor from we got that 0, from that factor. The multiplicity there is equal to 1. Now, whenever you have odd multiplicities, okay, like we do here, here, and here, so actually in every single example, it's always going to cross the x-axis. It's actually going to intersect and cross that x-axis. It crosses it, okay? If you had an even multiplicity, which we don't have in this case, but that's when the graph would just come down and bump and touch, so to speak. It just bumps a particular value, and it doesn't actually cross. It's just going to come down and boop, bump, all right? And why is that the case? Why do the odds and even multiplicities, produce different graphical behavior? Well, it's to do with the math, right? That's inherent in the function. And guess what? I have a video on that. All right. So check out the link in the description below. I go through why that is. If you're of a curious mind, check it out. Thanks for tuning in. I really do appreciate it. I hopefully will see you in the next video. Take care.